All right, let's talk about a super clever approach in machine learning called semi-supervised learning. It's built to solve a problem that is just so common. What do you do when you have a tiny little bit of perfect, labeled data and a whole mountain of raw, messy, unlabeled information? Let's dive in.
So, here's our game plan. First, we'll set up a really common data problem. Then, we'll introduce the brilliant best-of-both solution. After that, we'll see how it actually learns from clues, check out its real-world superpowers, and finally, figure out where it fits in the big picture of machine learning.
Okay, first up, let's paint a picture that I think anyone who's ever wrangled data will know all too well. It's that classic situation where you've got a little bit of beautifully organized, labeled information, and then just a whole lot of, well, everything else. And this, right here, is the fundamental question. What if you have just a few answers, but a ton of raw data? It's kind of like this. Imagine I give you a tiny, perfect answer key for a test. Awesome. But then I also hand you an entire library of books that haven't been organized or summarized at all. What do? How can you possibly use that tiny key to make sense of the whole library?
Well, the answer to that question is a huge yes, you can. And that's where our hero comes in, semi-supervised learning. This technique was literally built for this exact problem. So let's break down the two key ingredients. On one hand, you've got your labeled data. Think of this as that precious teacher's answer key. It's perfect, it's accurate, but man, is it expensive and slow to create. This is probably the biggest bottleneck in a lot of AI. But then on the other side, you have this mountain of unlabeled data. This is the rest of the library, right? It's messy, no answers, but there's just so much of it, and it's basically free for the taking.
And this right here, this is the whole game. If you remember one thing, this is it. Semi-supervised learning doesn't make you choose. It's all about using both labeled and unlabeled data to build a way better model. It combines them to create something so much more powerful than you could ever get with just one of them alone. This is how you smash through that data bottleneck.
Okay, so you're probably wondering, how does this even work? I mean, how can a giant pile of data with no answers help you at all? Well, it's kind of like being a detective. It's all about finding the hidden clues that are buried in that big, messy pile of data. This is the secret sauce. That unlabeled data, it's not useless just because it doesn't have answers. Not at all. It actually holds the key. It's like a map to the underlying structure of all your data. It shows you the natural groups, the hidden relationships, all the patterns. It gives you the big picture context.
Let's try to picture this. Imagine a graph, okay? You have a handful of blue dots over here and a handful of red dots over there. These are your labeled points. But then, surrounding them is just this giant cloud of plain old gray dots. Those are your unlabeled points. So the big question is, can all those gray dots actually tell us something? Can they help us figure out where the real line between red and blue should be drawn?
And here's the model's incredibly smart strategy. Step 1, it looks at that whole gray cloud of unlabeled data and finds the natural groups, or clusters, on its own. It just sees how the data is shaped. Step 2, it takes your few labeled points, your red and blue dots, and uses them like anchors. So if a red dot falls into one of those clusters, the model goes, aha, this whole group is probably red. And step 3, it intelligently spreads those labels out to the rest of the data. It basically uses those few starting clues to label the whole shebang.
Now, this isn't just some abstract theoretical idea. No way. This technique has some serious real-world superpowers. So let's check out a few places where it's really making a difference.
I mean, just think about the possibilities. For image classification, you could just label a few cat photos and a few dog photos, and then unleash the model on literally millions of unlabeled animal pictures from the internet. Or for text classification, you can make your spam filters so much smarter by letting it learn from a giant pile of unlabeled emails. In medicine, this can be a game changer for finding patterns in huge patient record databases. And in speech recognition, this is how you make voice models better by feeding them vast oceans of unlabeled audio. The applications are, well, they're everywhere.
Okay, to really nail this down, let's see exactly where semi-supervised learning fits in with the other big learning types you've probably already heard of.
Yeah, this table lays it out perfectly. You've got supervised learning, which only uses labeled data to predict something you already know how to define. Then there's unsupervised learning, using only unlabeled data to find hidden patterns you didn't even know were there. And then, smack in the middle is our hero, semi-supervised learning. It uses both, and its goal is simple: make better predictions.
It takes the predictive power from supervised and just boosts it with the structural insights from unsupervised. Truly the best of both worlds.
So if there's one idea to walk away with, it's this. It really is like learning with just a few solid answers and then a whole lot of exploration. You get the clues, but then you have this massive world to explore to see how those clues fit into the bigger picture. That's what makes it so powerful.
And there you have it, a really powerful technique that lets you make the absolute most of the data you actually have, not just the data you wish you had. Hey, if you're enjoying our journey from math and machine learning, please don't forget to like the video and subscribe. That way you won't miss the next step in the journey. Thanks for joining me.